In some applications, we are not given ordered pairs, so we have to know how to build a linear model from a verbal or written description that doesn't involve given ordered pairs. Here are the steps we'll follow. Step 1. Determine the value of the fixed or the original amount. Step 2. Determine the slope. Step 3. Write the linear model, and for us that's a linear function. In step 4, we'll use that model or linear function to evaluate the function, and then we can also create a graph. So with our second example of applications of linear functions, we're going to be determining total cost. The scenario says a developer prices condominiums in Florida at $20,000 plus $40 per square foot of living area. We're going to express the cost, C, as a function of the number of square feet of living area, S. So our variables are already given to us. It says cost is a function of square feet. So that means cost is a function of S. Then we'll find the price of a 1,600 square foot condominium. Last, we're going to graph the linear function. So going back to part 1, express the cost as a function of the number of square feet. Alright, so we've started with this notation, cost is a function of square feet. To get the rest of this linear function, we'll go back to the scenario, and it tells us that the developer prices condominiums at $20,000 plus $40 per square foot. So per square foot says 40 needs to be multiplied by the square footage. So we will have $20,000 added to 40 times S. Now I'm thinking about linear equations, so I want to put 40S first and then add the 20,000. The only reason I'm doing this is because now it looks more like our slope-intercept form. Remember y equals mx plus b? So that's why I'm writing 40s first. I can now answer question 2 because we have our linear model. For question 2, we're looking for the price of a 1,600 square foot condominium. So 1,600 is our substitution for S. We're really looking for C of 1,600. So simply make that substitution, and when we multiply 40 times 1,600, we're going to get 6,400 added to 20,000. So the cost of our 1,600 square foot condominium is the sum of these values. That would give us a dollar value of $26,400. What we've actually done here is generated an ordered pair. Our input is square footage. Output is cost as a function of that square footage. So with our table, we've generated our first ordered pair of 1,600 square feet has an output of $26,400. Now since that's only one ordered pair, that's not enough information to draw the graph. What would be helpful is the y-intercept. So when our input is 0, we'll be able to generate an output that represents the y-intercept. So we're looking for C of 0. That would equal 40 times 0 added to the 20,000. Well, obviously 40 times 0 would be eliminated, so C of 0 would be 20,000. So we have at least 2 ordered pairs to plot. Now when we go over to the graph, we're going to have input values S. That's square footage of living area. Could that ever be a negative number? No. So we only want 0 and positive numbers for our living area. If it's 0, that means you have no condominium yet. And then our other variable, output, is C of S. That's cost in dollars. So if you're paying for the condominium, you're not going to be allowed to pay negative dollars. So we only need positive values for C of S. So that tells us that we just need the edges of this grid or the positive values only. So there's one axis and our other one. So we've got our axes labeled with the variables, and now I need a title here for the C of x that was going to be our total cost in dollars. So be sure to label each axis with the variable that represents it and with a title. Otherwise, you won't know what you're looking at. So be sure to include the labels and titles. Now we need a scale to accommodate our numbers. Our lowest value for S is 0, largest is 1600. So I could count by 100ths. Now since these are so close together, it would be difficult to write the value for every single line, so I'm going to skip a couple of lines and label those. So if each one is worth 100, I might start off by writing that first one so we know what the established scale is. So our scale will accommodate 1600 square feet. With total cost, our largest number is 26,400, so we need to make sure that our scale will accommodate a number that large. So I'll count by 2,000. So each line will be worth 2,000. Next I'm going to plot the ordered pairs. So we have 1,600 and just a little past 2,600. And then we have 0, 20,000. We'll draw the line to connect these ordered pairs. And then we have to think about dots versus arrows. So at the y-intercept 0, 20,000, if we go to the left, that would be negative living area. That's not possible, so that remains a dot. On the right-hand side, or on this end of the line, we could go larger than 1,600 square feet. So I'm going to extend that line and be sure to use an arrow to show that it can continue in this direction. And you may want to title the graph as total cost by square foot. One other thing that we could mention about this application is the domain and range. Even though it wasn't specifically asked for, it's always a good idea to make sure that the domain and range that you've graphed would make sense for the application. And we really did need to take that into consideration when we talked about dots versus arrows. So the domain here is our living area. It could be as small as 0. And since we have an arrow going to the right, it's an unlimited amount of living area. That's infinity. With our range, that deals with the cost. So the lowest price would be at this y-intercept of $20,000. But notice, since this is a positive slope, the cost is rising as you go along the line. Again, into the arrow means going to infinity. So the cheapest condo is going to be $20,000 going to infinity.